Hello, everybody. Working on a project today, the spinal cord track project. I'm going to try to use some tools specific to sync sessions. So I've got my Zoom open. I'm recording it just like we would be doing if it was a live session. So that was my goal, is I wanted to work through these tools as a live session. And so I've got some screenshots up. I really would like to find the ability to have a great whiteboard and a mouse that worked good with it, but I haven't found that yet, or I found that ability yet, at least with the mouse and the tools that I have here. So to that end, let's get going and take a look at this. So the assignment, welcome class. We're here tonight. We're going to look at some spinal cord tracks, and we're going to work through these tracks, the ascending tracks, descending tracks. In particular here, we're going to start focusing on the dorsal columns. Now, when I was in school, I learned the dorsal columns is that higher order fine motor skill element that is so important to humans. So let's take a look at first. I'm going to share my screen. We're going to take a look at first here a hemisection of the spinal cord. So here we go. This is a hemisection, and let's look at a few structures to start with. Let's just get oriented. So first, gray matter. Gray matter is that magic butterfly inside. So I'm going to turn on some ability here to do a little fun drawing on here. And let's go for some orange. So that gray matter that we're going to start, here it is, this area right here, this magic little butterfly, all the gray matter. Okay. Now, that gray matter is the thing that all comes in, the connections are made either at the segment level, or they may send them then up a level, down a level, or up the spinal cord to the brain, or down out into the body for some type of action. The white matter, let's look at the white matter. Let's make that one purple. So the white matter is going to be all of this area that then surrounds it like that. So there's the white matter, all the white matter there. And there's where we're going to start to talk about tracks, where information goes up the spinal cord and information goes down the spinal cord. All right, so let's clear that off. Now, another one, dorsal root. Dorsal root's important to identify. Dorsal root itself, again, will be in that posterior aspect of the spinal cord. Dorsal root. The anterior, or excuse me, the dorsal root ganglia then is this element that we see as it comes out from that dorsal root, and it comes in this little bump that we see there. That's the dorsal root. Perfect. Then we'll see the ventral root, the front side right down here. That's the ventral root. Okay, so the dorsal root ganglia, and the ventral root. So we've got all those structures identified. Beautiful. Now the spinal nerves will form a combination of the dorsal root and then the ventral root. And they'll come together, and right here will form this spinal nerve. Of course, we've got 31 pairs of those up and down the spinal cord. And that's a big part of what we see and what we're doing in terms of our sensory evaluations, in terms of dermatomes, and we see those patterns from those spinal nerves. Now, the nerves themselves will break into a dorsal rami and a ventral rami. And I'm actually at the end of the slide here. I can't go any further. Let's see if it does it on this side here. Dorsal rami and a ventral rami. There we go. It does it on the other side a little bit better. There we go. And they'll break into two elements there. The dorsal tends to come back and innervate the trunk, and the ventral then tends to go out to the body. Now, another big element that we have to be aware of and remember, the terms afferent or sensory and efferent and motor. So those sensory nerves, those afferent nerves, what they will do is they will come in from the periphery. They will come in, they'll go to that dorsal root, and they'll actually come here, and they'll little dorsal root ganglion there, and they will come in that dorsal root, and they will form some type of connection. Maybe something at the spinal segment level, or it may then a reflexive type thing, or it may go some information up the spinal cord. The efferent then is created by some type of action, again, maybe higher order, maybe it's at the spinal cord level, but there will be some type of connection then that goes out that ventral root on out, joining up with the afferent elements to make that spinal nerve. So posterior coming in the dorsal root, that sensory, that afferent, leaving out through the ventral, that efferent, that motor. And that's kind of what it looks like. Now we're going to look at, particularly in this case now, we're going to look at the dorsal columns. And the dorsal columns are going to happily sit right back here. These are the dorsal columns in this area. Okay. This area right back here. So these are columns that are formed. Information will come in and it will ascend up the spinal cord. And let's look specifically at that information. Okay. All right. So I'm going to stop sharing that. And I am now going to share a new screen. Hang on just a second. Okay, now I'm going to share that screen. We are now going to see, and what you should be seeing now, blow it up a little bit, posterior column, also known as the dorsal column, could be the dorsal column medial lemniscus pathway. First order. Now we have three orders of connections. Again, information's coming in from the periphery, comes into the spinal cord, actually ascends the spinal cord. We're going to come up to the level of the brainstem, and then we're going to then project information from the brainstem up into the brain. So first order, second order, third, those three connections that are made. In the dorsal columns, or the posterior columns, that information will come in from, and excuse me, that information will come in from the periphery right here in the form of vibration, proprioception, light touch. And that information will come into that dorsal column, come in through that afferent pathway, and then that information is immediately sent up the spinal cord. It goes right up. There's no synapse going on there at the local level. So that first order comes in and goes right up through what we call the gracile fasciculus and the cunate fasciculus. Generally, the gracile comes from the lower body information and the upper body comes from the cunate. So that information goes up. The first order goes up all the way up until it hits. Let me erase that information there. And that second, it goes up in synapses with the gracile nucleus and the cuneate nucleus at the brainstem level. So here we'll start to see, here's the nucleus gracilis and the nucleus cuneatus. Okay, it comes up, that information goes up, Synapses right there. So again, highlight on that part. Information comes in and it goes up. And once it gets to the level of that medulla, it forms or it has the synapse, and that is where we'll have the decusation or the crossing. Okay. So that leads to the second order. So the second order is once it synapses there, it will actually cross over the what we call the sensory decusation, forming that medial lemniscus, and then it connects up with the thalamus. So in that information itself, we're going to see it's going to connect, it's going to loop over through those internal arcuate fibers, and then it's going to ascend, and it's going to go up, forming the medial lemniscus pathway, and it's going to go all the way up until it hits that third order, which then gets us to the sensory motor cortex. So first order, the information comes in, it ascends up through the dorsal columns. The second order happens at the brainstem, that level there with the nuclei gracile and the nuclei cuneate, crosses there, and that internal the internal arcuate fibers crosses over and then ascends all the way up to the sensory motor cortex. All right. Now, what the information that's carried here along this pathway is, again, very high order information, fine touch, vibration, 2-point discrimination, proprioception from the skin and the joints. This information is transmitted to that primary somatosensory cortex in that post-central gyrus region of the parietal lobe. All right, stop sharing this screen. Now we're going to look at what does this mean in terms of some type of dysfunction we may see as clinicians. All right, I'm pulling up the next slide here that we're going to see. And we're going to start talking about a posterior cord syndrome. Okay, posterior cord syndrome. And this is very specific to those dorsal columns. So again, here, a little orientation. Again, we see that dorsal root, dorsal horn, that ventral horn here. We don't see the dorsal ganglion, the spinal nerve, or any of that coming into these elements here, but that's where they would happen. But we see highlighted here that posterior element that forms the posterior columns, the dorsal columns, and then this is the area that could be damaged, producing a syndrome called posterior cord syndrome. These injuries usually are from direct impact. It could be from hyperextension, either from compressive forces or something traumatizing that part of the spinal cord. These lesions present with a loss of deep touch, position sense, vibration sense, all below the level of the lesion. However, there's a preservation of power and pain and temperature because all that information is carried in a different part of the spinal cord. The important thing to understand here, when we see these patients, again, we've lost these higher order skills, the body sense, the awareness of where we are in space. This loss of proprioception is critical and usually is very difficult to overcome. When it's lost, it's very difficult for these patients to function, the ability to walk, to get the understanding of where they are, even though their motor may be intact. These patients are having a very difficult time of placing themselves in this or understanding where they are placed in the environment around them. So posterior cord syndromes are very devastating, and also can be very frustrating. But again, they're losing that position sense and that vibratory sense, the proprioception. So even though the limbs can be moved and even though they can feel pain, it's very difficult for them to have any type of functional gait. All right. I'm going to stop sharing there, and we're going to check the chat, and we're going to check, open it up for any question and answers, and we're going to go from there. So, all right, question and answers.